Okay, in this video I want to show the shortest path from point S in this top and front view to the plane WXYZ. This could represent a tunnel to a stratum in a mine or a pipe to the side of a hopper or something. Anyway, we want to find the shortest distance perpendicularly, as well as the shortest horizontal distance to the plane, as well as the shortest distance at a given angle. We'll use 35 degrees. So first one, we'll use a perpendicular, the shortest actual physical distance to this plane. So the first thing to do, I already have my construction layer on. I'm going to draw a horizontal line through point Y and find where that intersects the line WX. There it is. So that line is in true length because it's parallel to the viewing plane in the front view. In the top view, it has no depth to it. It has no elevation change, in other words, in that top view. So this line from point Y to where it intersects the edge WX is in its true length. Therefore, I can draw this plane in a edge view by, I'll use my phantom layer, draw a line perpendicular, and this will be my reference line for this plane. I have to lengthen that. Okay, so this point, this line, this true length line in the top view will appear as a point. So I want to find out where that point is, and then I can draw the edge view of this plane in this auxiliary view. So now, back to my construction layer, draw a circle from point Y. So that's the elevation, or the distance, from below the plane. So that plane is represented also by this line at a different angle. So I need to extend or lengthen out this line. Nice long line. In fact, I'll make some copies of that, all being parallel at the other points. I feel like I didn't get that quite there. Guess so. Okay, now I can copy that elevation at point Y, where it intersects. So right where that point intersects will be where that true length line exists as a point in that view. So I just need to get some more distances under the plane. I have to extend that line. Intersection. Okay, there's WX. I really don't have to have all the other points, but let's just go ahead and, for academic sake, get the rest of them. We need Z. Okay, should be able to just draw a line between point X in this view and Z, the furthest, And it should pass through all the other intersections, that line. So where that line goes, that would be point W. This would be point Y, and the other point that I didn't label. There we go. Okay, so now I have the plane in edge view. Get rid of these circles. Where's S in this view? Need to place that. So another line here to copy that point S. Move my circle to where that line, that projection line from S meets. And I'll go ahead and copy point S over to where it intersects there. So I don't need that circle anymore. Okay, the shortest line, go ahead and draw this one on the object layer. It's going to be from point S perpendicular, because the shortest distance between any two lines. So any point on that plane and where point S is, this is going to be a perpendicular line to the plane in edge view. So there it is, the true length line of the perpendicular distance from point S to the plane. Well, where is that point in the other views, right? So let's go ahead and copy this line again. So if I project that point back to the plane, well, where is it? Right, so this line, because it's perpendicular to the plane, is also needs to be perpendicular to this plane. It needs to be perpendicular to the line of sight in the top view here. So this line is already in the object layer from point S perpendicular to the projection line. And this is the line that the shortest distance to the plane. And it is penetrates or touches the plane at this point. Now, is this line hidden, or is it an object line? Is it visible? Well, because, well, in both views, in both profile views, the auxiliary one and the front view, I can see that it is below, both points are below the actual plane. So, in fact, this one should be hidden. So that line is hidden, it's below the plane in the top view. Okay, let's jump over to a horizontal distance. So if I draw a construction line horizontal at point S, this is the line that we're talking about, and we want to know where that intersects the plane. Well, it doesn't look like it intersects the plane at all in the front view here, but what we do know is in the auxiliary view, if I draw that horizontal line, it needs to be, well, in the front view it's horizontal and it looks horizontal, but that's only because it's parallel to this reference line. So I just want to draw another line parallel to that reference line on this point. So I'll just draw a parallel line here, and I'll need to extend my plane, being an edge view, a little bit further, and this is where it's going to intersect the plane. Remember, this WXYZ represents an infinite plane, so I can extend that in edge view to where it intersects. So let's copy this again. And project it back to the top view. So where does it intersect the top view? it intersects the top view where it is parallel again to the reference line, as it turns out. So I'm going to draw another line from point S to where it intersects perpendicularly to this projection line to the plane. So this line is where a horizontal line from point S will intersect the plane. Now, is it, as far as visibility is concerned, is it hidden or well, if this plane represents an infinite plane, kind of doesn't matter, but if this does indicate an edge, then it wouldn't intersect at all, I suppose, but it would be hidden below that plane until it was closer to the reference line outside that. So one thing you can do is just break this line at a point. So I can break that line right at that point, and I can treat it like this. So in this case, this is the horizontal line that is underneath the plane, and this is where it comes back out from underneath. The next line that we want from point S is at a 35-degree angle. Now recognize, I hope we recognize that this line is in its true length, as is the perpendicular line. So this horizontal line is just horizontal because it's parallel to the reference line. So all I have to do is rotate this my 35 degrees. Let's go ahead and rotate that with the copy command, and we'll go 35. So now this line and where it intersects and this line where it intersects the projection line is the length of a 35-degree line from point S to the plane. So all three of these lines are true length in this elevation view because we have the plane and edge view, and are collinear in the top view. So there you have it. 3 lines perpendicular, horizontal, and at an angle, any angle you want to choose to intersect a plane.